Hello? Okay, cool. All right, everybody, today I'm going to talk to you all about shells. Okay, I am Draden, a freshman in CSEC. I do CTFs and stuff, jiu-jitsu, and sometimes I like to jump out of planes. Today we're going to go over, first we're going to go over some tools and terminology. And what we're going to be talking about, we're going to need to know what is Netcat. It's the Swiss Army knife of networking. Later we'll talk about some reasons why you might need to use Netcat traditional. You can use this to mainly perform network interactions, and it's usually pre-installed on Linux. We're also going to be talking about SoCat. This is Socket Cat. It is typically called Netcat on steroids. Has more functionality and more stability, but it's usually not pre-installed. And we'll talk about some of the limitations there later. It's also the Metasploit framework, which you can use to create payloads and catch shells. All right, so what is a shell? A shell is used to interface with a command line interface. So like bash or sh programs on Linux, cmd.exe, or in PowerShell on Windows. It's really good for initial access if you have RCE, so it's something you want to try to develop. If you have some sort of like a web shell and you just see like, oh, I have row command execution, let's just get a shell going. And we're talking about the difference between a bind and reverse shell. A bind shell, I guess that's going to come on later. So what is an interactive or non-interactive shell? An interactive shell can send input to programs that's running in the shell, and a non-interactive shell cannot send that input to programs. This is very important. So if you tried to SSH an interactive shell, it's going to work. If you try in a non-interactive shell, it is not going to work. You'll also not be able to use certain programs that take up the whole screen, like text editors. Vim won't work, and for any of you nano users, that definitely will not work, and you deserve it. So next thing, what is a bind shell? A bind shell has a target listening on a port attached to a shell, and this is exposed to the attackers. And the attackers will connect to the port to get the shell and start interacting with the system. So some considerations to have for this are going to come later after this how-to slide. So an attacker here will NC to blueteamer.sad on the leap port if they're using Netcat. And a victim will be listening. And then this TAC E flag is to essentially feed their shell into the Netcat listener. If there's an error with that, you may need to use netcat.traditional or nc.traditional if you're on a Linux system. If you're on a Windows, good luck. Try and find a different compiled binary. One or the other. And then SoCat has different syntax. As you can see, it's less simple, but it still works. It just has that exec option. If you'll notice here, we're also passing pipes, and this forces it to use like Unix style, like standard input and error, and have it work with the listener there. And SoCat, same, just TCP, blueteamer.sad. Some considerations for bind shells. They're not good for pen tests generally because it'll expose your client's systems to anyone connecting from the outside. And you don't want another person to use that shell. You'll also have to consider firewall rules that might prevent you from connecting to any ports that are just open on the network. So with that, we're going to move into reverse shells, which are super cool. It's where the target is forced to connect back to an attacker. And this can generally bypass firewall rules. And as a general rule, reverse shells are easier to execute and debug. So obviously, since it's the reverse of a bind shell, the attacker is going to be the one that's listening. And then the victim will be connecting to hacker.net and sending them bin bash or something similar if they're on Linux, or cmd.exe if they're on Windows. And again, notice that we're using pipes there because you want your shell to work if you're attacking someone on Windows. Considerations for reverse shells. What port are you going to be having the victim connect back to you on? Is any traffic coming out on that port suspicious? Will it look different than other traffic going out? how you're going to expose your attacking machine. You have some sort of C2, is it going to connect directly back to you? You have to worry about NAT or port forwarding on something. If you're one of those script kiddies at home using a router to set up a port forwarding Minecraft server. How will you get another shell if you are disconnected? Or like you disconnect from your shell, you forgot to stabilize it, you press Control-C, lose your shell, is it going to call back to you, do you have to do RC again? Something to be thinking about. We're going to talk about stabilizing shells, which is helpful for quality of life. There is a nice little Python one-liner there that is helpful. The next step is to export term, and that will let you use commands like clear. And then if you press Control-Z, that's going to background the Netcat connection, and then you type in that command there, scty raw tech echo foreground. That's going to let you use like some of your tab autocompletes, your arrow keys, and Control-C without it affecting your connection to the shell in general. You can also use RL wrap, but we're not going to cover that here. Moving on to detection. For bind shells, generally have some sort of port scanning. Reverse shells is coming up next. Both packet captures and analysis will help you for you blue teamers up there. So if you're on Linux, you can list open file descriptors by IP. So 0 is standard in, 1 is standard out, and 2 is standard error. So you might want to notice here at the bottom in this highlight, you have bash and standard input, output, and error are being redirected somewhere else. That's a little bit suspicious and might warrant some investigations. Normally, if you're a blue teamer, you won't see a C2 executable over there, but that's just because this is a personal server. And here you can see, this is for bind shell, where it's just listening in that top screenshot. That's where I had to use nc.traditional because on some versions of Netcat doesn't support that TAC-E option. So it's just listening, and then after connection, you can see the standard input and output are going out to the outside IP. Then you can also use Netstat or SS. Thank you, Michael, for somewhat covering those. As he said, Netstat is deprecated, so use SS. You can get information about sockets, what sockets are listening and established, remote IPs. SS will get you the socket statistics. Packet captures are also helpful. This is something I captured when I was testing. If you see who am I, root, or some of these similar conversations between two IPs, that's also suspicious, and that would warrant some investigation. But let's obviously investigate if you see something like this. What this won't detect: advanced agents or implants. There's not too much to say about that. For further resources, you can check out TryHackMe, Rooms, What the Shell, and Metasploit Exploitation. What the Shell is a very good room, and it also go over how you can encrypt the traffic over your sockets, which means that that packet capture that I showed you, that screenshot, would be essentially useless because you wouldn't be able to read it. And if you had it connecting back over port like 443, it looks like normal traffic more or less, depending on your domain. You can also look at payloads, all the things for different kinds of ways to get reverse shells and bind shells. One-liners are nice, and Pentest Monkey has similar resources. Are there any questions? Okay, thank you, and I hope all of you go and talk to Megan. She has been very helpful to this department, and we are sad to see her go.
Hopefully that wasn't too loud for the stream. All right, thanks, Draden. Thank you for an amazing presentation, as always. Thank you. So yeah, that's going to conclude the research presentations for this